And yeah, I guess we can go ahead and get started. So hopefully everyone had a good break. I certainly did. It was not long enough. So here we are back again to statistics. And so I guess the first question I want to ask, I guess this will be more prevalent to the people in here physically. How many of you took 105 last semester? Okay, well, yeah, the topics in 241, if you did take 105 last semester, you're going to see some of the material, say, not today necessarily, there might be a bit of new terminology, but you'll see things, you know, the mean, the standard deviation, all those things. You'll see topics like that show up later on. And so it does lead into a natural extension of Math 105. If you have not before, I'm going to explain everything as if you haven't heard it before. There's really no prerequisite for this class that I'm aware of. But I suppose I guess the first thing I want to talk about first is really the way you all communicate with me. Now, in class, this is a lot easier because you just raise your hand and talk to me. And so, for those of you who might have had me last semester I didn't bother trying to figure out how the speaker system worked. And now this semester, I think I have it. So maybe one of you at home attending virtually can see if you can turn on your mic and ask me a question and test the system out, because I think I have it working. So any one of you attending virtually, you'd like to turn on your mic and just say anything, that would help me out. Any one of you, or I'm going to call one of you out at random.
Hi, how are you today?
Catherine, awesome. I can hear you just fine. All right, that's perfect. All right, that's all I needed. So it works. So if you have a question virtually, and this just goes in general, you could just ask me, because I used to check the text box, and it's very tedious. So if you want to ask me a question, you have to unmute yourself. As you can see, I don't know what it looks like on your end, but you have to I think it's down here. So you unmute yourself and then talk to me, because if you're all muted by default. So you do that, then you ask me a question. Hopefully it should work out just fine. If not, try the text box and I hear a little jingle or something whenever it goes off. So hopefully that'll make things a little bit easier moving forward if you're attending virtually and all that stuff. So yeah, if you want to attend both days, we have a fairly small class size. There's 24 students. So 12 and 12. So if you want to attend both days, really you could just show up both days. If you let me know, it gives me an idea of the numbers to expect, but really I'm not expecting that we're gonna fill the classroom by any means. And besides for that, so that takes care of communication and of course Google Meet. I'll stream these, I record my lectures, and then I normally post my video lectures to YouTube and provide a link through the online portal we're going to use. So if you were in my 105 class, then same thing as last semester. If you weren't, I'll kind of show you what I'm talking about as really, it'll be more prevalent after I post this recording that you're listening to right now. So I guess the natural extension is to go into Moodle. Right, I am sharing my screen, so hopefully everyone can see this all right. So in Moodle, we're not really going to use Moodle too much. What's more important here, so of course I have the syllabus here. I'll get to the syllabus in a second, but mainly I have signing up for my stat lab. So we do use a MyMathLab type environment. So for some of you who didn't like MyMathLab, well, we use MyStatLab, which is very similar. It's the same interface, just different problems. The good news is the stats here is not finite math, or it's not college algebra if you took that last semester. Stats is completely controlled by me, and unlike finite math and college algebra, I have full control over this class. I get to do what I want. That's very nice. It means I'd like to throw in a little bit of variety, but also not, especially for those of you who took college algebra, not make it as vigorous as those classes. I'm not focusing on that as much. This isn't so much computation. There's a lot more art to this. There's really a whole process when you think of statistics, as we'll talk about mainly in this first section. And so that's primarily what I want to focus on, not a bunch of arbitrary problems that go one after one after one that are seemingly endless and gratuitous in nature. So rambling aside, there is signing up for my stat lab, which I noticed a lot of you have already utilized. So there's a bunch of you already that have already signed up for the class. So that's fine, that's awesome. If you have not, go through this document. It should be really straightforward. You follow it step by step. If it asks you for the course ID, then it's right here. If it asks you for the access code, it's right here. So I'm not really going to, I guess, spend any time, I guess, hand-holding with this process. It should be straightforward. I saw over a third of you have already signed up, and I'd imagine the rest of you shouldn't have too much issue with this. So go ahead and sign up soon, definitely soon. You definitely want to sign up soon. And the syllabus is posted there, so I'll go ahead and talk about the syllabus once I go over to that side of things. And so it of course will look different on your end. As you can see, I teach a lot of classes this semester, but this is our class. So currently there's 12 of you signed up. So that's half of the class already, so that's perfect. And so mainly, if you haven't done so, just get used to the interface if you haven't dealt with it before. If you have, then it's really similar to what we've dealt with before in terms of Math 105, 151, 161 students. It's pretty much the same interface. You have just detailed assignments that pertain to a section or group of sections, and we have quizzes. So it's the same idea. And there's no due dates because really I'm going to update the due dates. So again, this is a class I tailor. So really the due dates will be synchronized with how quickly or not quickly I finish the material. And I'm not intentionally trying to, shove too much work at you all that exceeds the requisite material that's required for this course. So these due dates, I'll populate them in time. I'll talk about the due dates after I finish each corresponding section, and we'll go from there. Course notes. So I was very much tardy in getting these course notes up. So I've been begging for many semesters to teach this class. I'm very excited that I finally get to teach it. And now I have an opportunity to type the notes. The problem is when I start from scratch, it takes a while. So these notes, again, if you had me for Math 105, you should be familiar with all of this. But if you have not, I post the course notes. I go through the book, I go through the homeworks, and I try to pick out all the things that are fairly representative that should give you a good overall idea of the topics you need to know. And I try to throw in some variety as well. I do recommend, as hopefully I get these out a little bit sooner instead of posting them at 2 in the morning, I do recommend you print these out so it's less evident in this section here because this is more descriptive, but when we get to examples, I do leave intentional blanks. So that way, when you do print out, if you do choose to print out the notes, all you have to do is write down the answers in the blanks instead of having to write down these really long questions, which may take a while. And as we get further in the stat class, there are a lot of word problems that are very wordy, and it's just a waste of time to write down the questions. So I figured I would just expedite the process and I guess facilitate the majority of the writing on my end. And you can focus on writing stuff and listening to my boring voice. So, and yeah, we'll go through all of these. So we'll be able to cover these 2 sections in class today, I believe. So we'll get back to that in a bit. So course notes, that's one of the tabs here. Go ahead and print that out at your convenience. And course documents, very simply, there's the syllabus. And that's a perfect segue to go into describing the syllabus. So let me go ahead and download that. We'll talk about what to expect in this class. So the syllabus is posted here and in Moodle. But so of course I am, well, just call me Brad. I don't care for the Mr., professors, all that stuff. You can if you want. Some people want to anyways. Just call me Brad. I'm not old. I don't like being called Mr. So just call me Brad. Class times, of course, Monday, Wednesday, 8 a.m. to 9:15 and meet 2:15. So if you're here physically, you already know that. If you're virtually for now, then make sure you come to the right place when your group meets. Office hours, I still need to figure those out. That's still contingent on a few things, but mainly if you ask me questions or if you want to schedule a Google Meet, actually, you might actually be able to, I haven't been told whether we can have physical office hours yet, where you can actually come to my office, which I think I've only had 5 students in 2 years ever show up, but I believe you can now. I believe they're a little bit looser on those. I'll have to check, but that's a thing as well. But mainly you could schedule a Google Meet session with me. Just shoot me an email. Hey, can we talk about this? Sure. Pretty straightforward. Email address, brad.hall@SELU. You might see the name Bailey pop up a lot in emails I send out. So Bailey's real name, Brad's preferred. So now you see why that is. Course text. I think this is a fairly important textbook to get. This is Michael Sullivan's Fundamental of Statistics and other corollary words, 5th edition. I'm going to go off of this. It's not required, but it is helpful. I do try to abridge this book in my class notes. I think this is a fairly descriptive and informative book, but if you don't get it, it's not the end of the world. All your homework and quizzes are going to be online. So you won't need it to have to derive homework problems to write down on pieces of paper. Course content, I stole this from Leonet. We'll learn about all these things as the semester progresses. The required materials, it does say course textbook, but again, if you don't have it, it's not the end of the world. Mainly what you need is one of these fancy TI calculators, which just had mine lying around, I thought. Oh, there it is. So one of these TI 83, 84, 89, if it says plus, if it says C or some other letter, it doesn't matter. Just some TI 80 something calculator. If you're thinking, does my, to show another example, if you're wondering, does my college algebra calculator suffice? The answer is no. This thing's not powerful enough to do the things we need to do in this class. So this won't be able to do, say, find the mean. or if it does, I've never looked into it enough to determine that. This calculator will be the calculator that I reference throughout the semester. And despite the changes in the number, the functionality and the interface is fairly similar throughout all the models. Give or take a few idiosyncratic methods that we probably won't even touch. And I also have required materials if Southeastern goes into the remote phase. So if the COVID gets really bad, then there is an academic continuity plan. And that means we will switch to ProctorU. Now, this is probably to the chagrin of quite a few of you who may have used ProctorU, but hopefully we don't have to touch ProctorU. My goal is that we do not touch ProctorU at all. And as far as I've been told, final exams are not remote, unless that's changed. But I've not been told one way or another. I'm hoping they are in person. Grading scale, pretty simple. Every assignment is worth a fifth of your grade. We have 2 exams and a final. So I did not want to do a giant midterm and a giant final that were worth 30% each. So I worked in 2 exams and a final. So it leaves a little bit of, I suppose if you bomb one of these, then it's not completely the end of the world. There's also the homework and quizzes, which the homework and the quizzes I'll talk more about here in a bit under remarks. And at any point, I reserve the right to proctor these through ProctorU if things go crazy due to the pandemic. So, but these exams, I plan on these exams being in person, paper tests. So, so as I mentioned, and as you might be familiar with, the homework and the quizzes, they're both assignments that are due on my math lab, as you saw under assignments here. Homework, of course, the blue ones, quizzes, of course, the ones that say quizzes. So the homework should be fairly straightforward. There's homework for each section or a collection of sections. If you're not familiar with my stat lab, my math lab at all, you don't have to complete the homework in one sitting. You can do part of it at some point, part of it at another point. You can do it wherever you want, really. You don't have to do it in any particular place. You don't have to turn in scratch work to me either. So you don't have to turn in any scratch work for your homework as well. You do it online, and I trust, or I hope that you understand why instead of clicking A, all right, that was wrong. Click B, all right, that was wrong. C works. You could do that, but the test is going to come around, and it's really going to hinder your performance in the class. And I guess, yeah, you must click the submit homework button in order for it to count. So pretty much once you submit your homework, once you submit your quiz, that's when it gets processed. The quizzes are a little bit different though. I'm going to give you 4 attempts for each quiz. If you took my class before, this was 10. I'm dropping this down to 4 because the quizzes go up in percentage. That means I want you to, when you attempt one of these quizzes, I want you to really think about it. That gives you at most 3 attempts to mess around with it and see what's going on. And then a 4th time to hopefully bring it all together and get a good grade out of it. And of course, the letter grades are pretty straightforward, 10-point grading scale. Makeups. Generally, I'm not going to offer makeups on the homeworks or quizzes, as I'm going to drop the 2 lowest quizzes and homeworks. So that's something that carries over from your 105, 151, 161 classes if you took those. But yeah, I dropped the 2 lowest homeworks, 2 lowest quizzes. And the final exam is cumulative. But just to reiterate, The exams, unless something goes crazy with the pandemic, I do plan on the exams to be in class. I may have these exams proctored in the math lab in the library because I can't fit all of you in here at one time. But the exams will be paper exams. So that's different homework and quizzes online, exams, paper, in class. That means by that point, you should 100% have a physical, tangible calculator, using your phone as a calculator. So I'm not going to allow the phone as a calculator. So you need to have a physical calculator by that point, especially. Definitely need to get it sooner though. I have some important dates here as well. First day of classes today. Some holiday, checkpoint. Withdrawal deadline. I'll probably send you, as well as your other teachers, will send you a mass number of emails when that time comes. Spring break, last day, final exam. And of course, the generalities. This is pretty much what you see on every syllabus. I don't curve, I don't offer extra credit. Cool. Seek help whenever a problem starts, not when you're on the third assignment and you've been struggling with the previous two, and then you realize you need help. That's a lot more ground to cover than asking me help in the very beginning. Makeups, excused absences. If you need any accommodations, you have to get these accommodations approved through Student Accessibility Services. I think they changed the name of it, it's the department, which is in Tinsley Hall, room 102. Tinsley is a little bit that way. And so, yeah, I can't provide any accommodations. Mainly time and a half is the most common one. So I can't provide accommodations without the accommodation office informing me of it. So yeah, don't talk in my class. Really, if I hear your phone go off, I'm probably going to tell you to, put it away, standard stuff. If I see you on your phone, you're probably going to do the next problem. So keep in mind anyone who I see on your phone. I'll have you do the next problem. I'll probably just have you come up here and do the problem. My 105 students know what I'm talking about. So just keep that in mind. It's very fun. Don't cheat, cool. And here's some resources. Yeah, sexual assault, if you have anything to report there. We have forms on that. And that pretty much covers the generalities and ultimately the syllabus as a whole. So with all of that wonderful information covered, does anyone have any questions for me before we start with the class? Well, you all figure that out. Get some more coffee. All right, so going once, going twice, cool. All right, so we can go ahead and jump right into the material. So as I mentioned, the course notes are posted in my stat lab, and you can download them. And I already have them up right here. So you'll be greeted with Math 241 notes. And I'll slowly start to fill this out as the semester progresses. These take a little while to type, so I'll try to work on them. I have the weekend to work on some. So we start off with Unit 1 on data collection. And we're just going to start talking about introduction to the practice of statistics, really. So really, what are statistics? How do we apply them? What does it refer to? And what are the characteristics of it, among other things? Statistics is such a broad term. It's such an interesting term too. I've always thought of this class, this is the most practical math class that we offer for non-science majors. The reason why, so here, I'm gonna ask you all a very honest question. Who in here has ever seen a statistic? You should all raise your hand. Statistics are prevalent everywhere. You may hear, so one of the examples I think of all the time, actually I might be getting ahead of myself. I'm gonna come back to that example I'm thinking of. But you might see it in a paper though, 54% of people do this. 68% of cars do that. There's all these numbers they throw at you. And mainly they like to throw these in headlines. It's these nice simplified numbers that give you perhaps a strong or a misled sense of describing a situation that may be occurring. And so a lot of people tend to think, or rather correlate statistics to numbers, a numerical analysis, which isn't necessarily true. Statistics is, although statistics highly relies on numbers, it's not the most contingent, it's not its primary contingency. In fact, statistics, that's a great segue for the definition here, it's really the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. So there's really a lot going on in that definition. It's not just about the number as a result, it's really about that whole process. How do you get the number? So you get, I don't know, you get these certain values. You have to do something with the values to get this, to get some number or conclusion from it. And then you have to think about how that applies to a bigger scope in some regard. So statistics really refers to the whole process. You might think, so statistics in the way it's thought of in a contemporary sense, that might be more so a statistic, singular, which we'll get to later as the overlying number. But in addition, so it's not just about having a concrete number, not just 64% of students blank. Statistics in a more practical feel, as we'll talk about later, gives us a measure of confidence in any conclusions as well. So you may get a number, but how confident are you that this number represents the thing you're studying? So these are questions that we will dive into as we progress through this section. And so, so again, I kind of talked about some of these parts already. If we break that first part of the definition into 4 parts, collecting the information. So if you're performing a statistical study, well, obviously you need to start with some information. How do you get that information? What do you do to get this information? Do you go online and go to a database? And if so, where does that database get the information? If you went out on the streets and got the information, how would you go about doing that? Who would you ask? What question or questions would you ask them? And then once you get this information, how do you organize and summarize it? So is this a ratio? Are you determining the percentage of people who answered yes in a yes/no question? Are you trying to figure out the average in a collection of numbers? Like if you go around interviewing people's weekly income, then you might find the average of that. So this would be the organization and ultimately the summarization. What does that ratio yield as a percentage? What does that average yield as a number? And then how do you analyze this information? What does this tell you about the population? So with this information you collect, pretty straightforward. You want to use this information to make some generalization, and hopefully a strong generalization about a group you are trying to figure out information on. If you're trying to, I have a colleague who I went to grad school with, and he works at Facebook currently, and his job is to figure out how to make people stay on Facebook. You know what he does a lot of? In fact, it was what his degree was in, statistics. You know how much money he makes a year? Way more than I do. There is a reason why this stuff is so prevalent. Imagine human behavior being quantified to a statistic or a collection of statistics. It's a very interesting science to predict what all of you, including myself, what drives us and what keeps us glued to a platform. And they do stuff like this for a job, for a very high-paying job. So, and of course, the last part, how convinced we are that our conclusions reflect reality. So we find a number. How confident are we that this number reflects the population that we want to know about? So really, this whole process is really what statistics comes down to. It's really what statistics comes down to. It's that whole process, not just a number, but where does that number come from? How reliable is that number? What does this number tell us? So this whole conglomeration of various facets of the statistical gathering and explanatory process. So very interesting stuff. Or I think it is. And we move on to really another key word here, another word you see a lot, data. Data, it's a very common word. It's a very general word. And I like the way the book defines it. It's a fact or proposition used to draw a conclusion or make a decision. So I guess to strip out the formality of that definition, the data is the information gathered. So if I were to ask all of you right now, I guess the common example I think of is, how much money do you spend in a week on coffee? Something like that. I could ask you, and then you, and you, and you, all of you, how much money do you spend in a week on coffee? Maybe zero for a lot of you. For me, it's too much, but all together, that collection of monetary values, that would be the data. That would be the information that I gathered from all of you. That example that I just expressed, that would be an example of numerical data. So it's a number. But you can also ask and record non-numerical things. Yes, no answers, that's one. Or perhaps if you are, if people are filling out a sheet and they put their gender on there, that's a non-numerical thing. If there was something sent out and it asked you of your political affiliation, Republican, Democrat, or Independent, those are non-numerical, but they can be recorded. So really non-numerical tends to lean more towards the categorical side of things, just various categories. And in general, data just describes the characteristics of an individual. So it describes you, describes me. It's things that I may belong to. It's preferences that I may have. It's any group I may be a part of. It describes characteristics of me and of you, of all of you. We've all had statistical studies performed on all of us. If you've ever heard of cookies on the computer, and no, not cookies you eat, but cookies as in, if you go to a website and it says, cookies will blah, 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 that tracks your internet history, and people will try to use your internet history and the places you go to, I suppose, promote products that they predict would be right up your alley. So we've all had statistical studies done to us time and time again. Schools, on the internet, it's happened to all of us and we didn't even know it. So how tragic. So let's go on a little bit more. So that's data. And just to add on some really important, I guess, terminology. So a population is the entire group that's being studied. So a population could be the student body at Southeastern. The population could be the citizens of the United States. Population could be students in this classroom. A population refers to whatever the group that is being studied or that you want to figure out some sort of some idea about. A population, a lot of times, could be with Facebook, could be the users on Facebook. An individual are it's the person or the object. So obviously this terminology corresponds to our intuition, I think pretty straight on. So an individual is the person or the object that's being studied. So individuals don't have to be people. They could be, say, models of television. They could be cars. They could be many different things. And then probably the most important word here is a sample. So a sample is a subset of the population that is being studied. So sometimes it's really hard to get information about every particular person, say, in the United States. So one of the big examples, every 10 years, the Census Bureau goes out and it tries to tally up all the people in the United States. And not everybody is represented in this tally for many different reasons. But what this tally does is it finds a sample of people, that is all the people that are in the United States that choose to be a part of the census. It tallies all of them and then uses that to generate a strong idea as to what the population in that region may be. And this is used a lot by the federal government for distribution of funding, as well as, I feel like I always get this wrong, the splitting up the number of, is it the House of Representatives? I'm not as good with my government stuff. The seats for House of Representatives, that's contingent. I know it's true for electoral votes. The number of electoral votes for each state is dependent upon the population. So samples in general are a subset that's used to make an inference about the population as a whole, which is exactly what I say. In fact, let me write on the screen for once. Samples are generally used to make inferences about populations. Sometimes it's not practical to interview or to survey every individual in the population, so you find a sample. So that's why it's important to collect data from a sample that's fairly representative of the population. So one of the examples I think of when I say that, imagine if I said that the average height of Southeastern students okay, all right, so I'll stick with that example. Imagine if I said the average height of Southeastern students is 6'4". What would you think about that conclusion? Seems a little fishy. I mean, I'm not the tallest person, but I don't think the average height is 6'4". Now, what if I told you that I interviewed out of everybody on campus, I interviewed the basketball team? You might think, well, that's pretty unfair. That's a very selective group you chose. That's not representative of the diverse collection of people on this campus. And you're exactly right. That is an unfair sample. That is not a very good sample. It does not represent the diversity of the people on this campus. Basketball players generally tend to be taller in physicality. So this would not be a good sample to choose. But even choosing the sample itself has its own field called sampling, as we'll talk about later. So that's why it's important to choose a valid sample so you can prove or disprove anecdotal claims. Now, if somebody wants to add the word anecdotal to their vernacular, anecdotal are casual claims. The book gave a good example of an anecdotal claim where when I was in high school, the first iPhone came out, and this was a big deal, so much so that people were on their phones now more than ever. That was really when I remember the transition of people being hunched over on their phones a lot. And this begged the question, well, I remember hearing a lot growing up at that point that, and people would claim it, phone usage will give you brain cancer. I heard this a lot growing up. I don't know if you all did, but I heard it a lot. And the book actually says that they have performed many statistical studies and they have not found a correlation between brain cancer and cell phone usage. The anecdotal claim was people saying with so much confidence that cell phone usage had a contribution towards or gave you a higher risk of getting brain cancer. And so statistics was used to disprove that. So I thought that was pretty interesting. So statistics, as you would imagine, is very powerful, but it works a lot more in your daily lives than you think. So really, and I want this to be a little bit more engaged for this next question here. Suppose you, one of you, were tasked with determining the average height of students in Southeastern. So if I gave you that task, just bam, try to figure that out. What would your process entail? Would anyone in here like to explain how they would go about doing such a thing? Jordan, what would you do?
Let's see. I'll start off with this class. 12 people. So I get everyone in here, I'd go through all the classrooms, and actually, I don't know.
I mean, hey, that's a good start. You'd go and just start collecting. You got to get data of some sort.
Yeah.
That's perfectly fine.
I don't know what building it is. I go to a building and get a sheet of everyone, like all the students, and I'd figure out where they are, and I'd call all of them. Oh, how tall are you? And they would tell me. So I get everybody's height, and then, add them up, and then divide it by how many people there are, and then out the average height.
Okay.
I don't know. That's a lot of college students.
That's a lot of college students. I wanna stop you and all right, Kyle. It is Kyle, right? Kyle, how would you get some more student names? Any idea? I mean, he's got a good one.
Probably like next semester, I'll probably make everyone like get a new ID or something, so they come to me, and then you can measure their height.
You'd make them. I was thinking, and I've seen this before when I was a student, people with clipboards outside of the student union, everyone who walks out, hey, what's your height? Most of the time they'd say, leave me alone, but hey, what's your height? Oh, it's, let's see, my example, I'm thinking 5'10" or 5'9" or something. All right, cool. So there's no right or wrong way of determining this. So that's not the end of the process. That's just collecting. So organizing is what Jordan was getting into. So organizing and summarizing this information. So as you mentioned, take all the heights that you collected. So if you want to find the average, you add up all the values and you divide by the number of people that you surveyed. Of course, that's the average. And then that number that you get, that would be, so let's say it's the average height in the US, like 5'6", 5'5", or something. I don't know. Let's just say you got 5'7". I don't know. Let's say you got 5'7". So then you would say, all right, the average height of students at Southeastern is 5'7", based off of either the idea that you used or Mr. Bureaucrat over here is going to get everybody to come to him for student IDs. But in any case, there's no inherent wrong answer to this collection process. But this gives you an idea of the process people have to go through. The sampling process. How you would get this information and then what you do with this information. So in this example, what's the population, what's the sample, and what's the individual in this case? So the population, sample, and individual. So Olivia, have any thoughts on the population, sample, or the individual? In this example, anyone? Want to give it a shot? No? Crickets? The population here, so who are we trying to generalize here? What group? Yeah, students at Southeastern. What would the sample be? Whoever you interview. Whoever will take time out of their day to answer your tedious questions. That's the sample. That's the people that you can get the data from. Who's the individual? The person. It all comes down to the person in this. Who are the people in the study or the objects? And now we get to an interesting question. Would your final measure be 100% certain?
That's where it kind of got me when you asked me that. I saw that. That's where it was difficult.
So this is when I wish I switched these two. I think I wrote this part at I think I got here at midnight. I wish I switched these two bullet points. So really I'm going to ask, if another student performed the same study, would you two, so let's say, Jordan, you did your thing, Kyle, you did your thing. You averaged your numbers and got some average height. Will you two get the same number? Why not?
Because they will collected data from different people.
Yeah.
Maybe.
I mean, that's perfectly fair. Your sampling process and your sampling process may be completely different, could be the same, which is very unlikely because there's a lot of students here. But that's exactly the reason why. You two would not get the same average. So what does that mean? Does that mean you're wrong, Jordan? Does that mean you're wrong, Kyle? It doesn't mean either of you two are wrong. It's just not, the number you get is not 100% certain because sampling processes can differ among whoever's performing the statistical study. So your conclusion here is you want to pick good sources and you want to have a sense of confidence that your average height is a fair representation of the population of Southeastern students as a whole. That's what you want to figure out. Sample or statistics is not used to find a definitive answer, but what it's used to do is to make an inference about a population by sampling, by performing a statistical study on a sample. And this is normally much easier because populations may be massive. And especially if you're talking about the variability of people, you definitely want a sample because, I mean, practically funding is a thing, time, all of these things, there's many other variables, but these are all particular things that people think about to think about how do I practically make an inference about a population, but I'm not wasting 10 years trying to collect samples. By that point, some of your data may be outdated. So these are all practical things that people think about. So statistics are not 100% certain, but they should provide you a level of confidence that a number you get provides a good representation of the population as a whole. So does anyone have any questions before I move on to the next thing? Okay, cool. So there's a few types of statistics. And so you might think of statistic, mainly the first thing I thought of was, don't be a statistic. The whole drug-free campaign, I would hear it from DARE when I went through grade school growing up. Don't be a statistic. So a statistic is a numerical summary of a sample. And so, so the average height that you got, either of you got in your theoretical study about the people you interviewed, that would be a statistic. It's a numerical summary of a sample. And I want to skip down here to parameter as well. So I want to look at statistic and parameter, and I'll get back to the other two here in a second. A statistic is a numerical summary of a sample. A parameter is a numerical summary of a population. So a parameter would be, let's just say you were able to get the result from every single person in your population. It's easier than it sounds like if your population is small. The average grade from a student in my 241 class, I can get all of your grades very easily. I don't need a sample for that. There's only 24 of you in this class. So really the best way, statistic, sample, parameter, population. And it's called an alliteration when consonants repeat. I can't remember. So if you need to find a mnemonic way of remembering statistic, sample, parameter, population. That's the associations, the first letter correspond. But mainly we're going to focus on a statistic and different types of statistics because we practically tend to deal more with samples rather than populations. Even though, you know, populations do come up as a whole in terms of studying them as a whole, but we'll focus on samples for now. And so there are two types of statistics. One of them is descriptive. One of them is descriptive. And me highlighting in this sense doesn't really emphasize one thing or over another. I could have emphasized every definition beforehand. So you know, everything's weighted the same in terms of importance, especially in this first section. They're just definitions. So descriptive statistics. So this might look familiar. Organizing and summarizing data. So that's the first part, or actually the second part of the statistical process that we talked about in the very beginning. So I go underneath the definition and I say that descriptive statistics, they simplify some data to mainly some concrete value. So back to the heights of the Southeastern students. The average height you got, that would be a descriptive statistic. It's just a singular value that represents all this data. Now I guess the antithesis, well, maybe not the antithesis, but Another form of statistics is inferential. Think about the root word here, inference. To infer something is to make some sort of, guess about it based off of some other related situation. So inferential statistics would be really a range of possible values that you are confident your average or someone else's average would lie in. So let's say your average height was 5'7", your average height was 5'6.5", and then I would come by and say, I am confident that whoever does the study, that 95% of people who do the study will get a value between 5'6" and 5'8". That is a very important aspect of statistics, giving a range of values, of expected values, not just a concrete number, but a range of concrete numbers. That is very important. In fact, that's a lot more helpful than just some number. So if you took Math 105, or if you have any experience with statistics, descriptive statistics would be the mean. Inferential statistics would be the standard deviation. So if those words sound familiar, so if you took 105, standard deviation, we talked about that. Standard deviation is primarily what inferential statistics are. That's the primary thing that comes into play. So how much more do I have left? Blah, blah, blah. Okay, let's move on. So example 1 here. So there's a question or two on your homework that asks you to determine whether the underlying value is a parameter or a statistic. Now remember what I mentioned. Parameter is population, statistic is sample. So we're figuring out, is the underlying number representing the whole population, or is it representing just a sample of the population? So let's look at number 1. The average score for a class of 28 students taking a calculus midterm was 72%. Parameter or statistic? Or in other words, does that number represent the population or just a sample of the population? Anyone? Okay, this is a population. The population here are the 28 students. This would be a statistic if I took, out of the 28 students, I took 15 random students and averaged their midterm exam. So the 28 students in the class, that would be the population, and since it's a population, we say that this is a parameter. Now for part 2, interviews of 100 adults, 18 years of age or older, conducted nationwide, found that 44% could state the minimum age required for the office of US President. Parameter or statistic? That's a statistic. I think that one's a lot easier to identify. What's the population? So the 100 adults is the sample. And one more thing. In the US, yes. The sample is adults 18 years of age or older conducted nationwide. That is, oh, darn it. Let me try that again. That's the population. And then the sample are the 100 adults within that. So this is a, darn it. I'll try it one more time. That is a statistic. parameter here, statistic here. So those are pretty popular statistics questions. This is a parameter or a statistic, and that's kind of the thought process that I would recommend. Does anyone have any questions before I move on? Not. We also have these things called variables. Variables as the characteristics. Let's try that one again. Variables are the characteristics of the individuals of the population being studied. Variables are classified into two groups. So characteristics of an individual, so obviously the data, where the data comes from, it's these various variables. So any characteristic of you, I would use hair color, but I'm not good with colors at all. So you know, types of shoes you all wear, that'd be a characteristic. Do you wear glasses or not? That'd be another characteristic. Is your hair over 1 inch? I guess that could be one. But there are two types of variables. Qualitative. This is qualitative. I think it might be easier to talk about quantitative first. Quantitative, well, quantitative is, the root is quantity. So this is a numerical measure. And more so numerical in the sense that standard operations of addition and subtraction can be performed and still provide meaningful results. I'll explain what that means in a second. Ultimately, not every number is a quantitative variable. Qualitative is the opposite. This is a classification based off of attributes or characteristics. And there's a few quick examples I have. Let's see, right there. And so we're going to go through all of these various variables. These are all various characteristics of people. We're going to figure out if they're qualitative or quantitative. So gender, that one is qualitative. Really, if one of these cannot be represented by a number, then that's going to be qualitative. So this is qualitative. Temperature, quantitative. Temperature 98.6 or 90, you have a fever of over some amount, over 100 degrees. I know that's definitely bad. That's quantitative. Height, that one's obviously quantitative. I'm 5'10", you're 5'6", you're 6'1". These are numbers. I'm 5 inches shorter than this person. They are 6 inches shorter than I am. Now, zip code. Is zip code qualitative or quantitative? Does anyone have a guess on this one? This one's going to be qualitative. So what's a zip code? It's a number, right? 70403. That's the Hammond area code. That's a number, but is that quantitative? No. If you add or subtract to that zip code, you get something that's entirely different. Adding 7 to that zip code doesn't mean anything. I don't even know if 70410, what is that 7 of in relation to here? This is qualitative. Just because it's a number doesn't make it a quantitative variable. What about your income? Quantitative. They make 2,000 more than I do. I make 5,000 more than they do. Something like that. That's quantitative. And then phone number. That will be qualitative again. That's qualitative. If I took my number and added 6 to it, what does that mean? It doesn't mean anything. If I subtracted 2 from my phone number, that is, if I even treated it as some integer, that wouldn't mean anything. It's a qualitative value. Adding and subtracting doesn't mean that you lose the meaningfulness of the number by doing that. And in regards to quantitative variables, there are 2 types of quantitative variables, so numerical variables. We have a discrete variable, pretty much it's countable, and then a continuous one, which is non-countable, so something that is a not countable value. And I have a few examples down here. We're going to determine whether the quantitative variables are discrete or continuous. So let's scroll down here. So the number of people in a room, number of people in this room, is that countable or not countable? 1, 2, 3, 4. Okay, that was easy. This is countable, so it's discrete. High temperature on a randomly selected day in Memphis, Tennessee. Is temperature countable or is it continuous? So this is where it gets a little interesting. Temperature is continuous. Pretty much the rule of thumb is if you can get a decimal out of it, chances are it's probably continuous, because decimals can go on forever and ever and ever. When we think of countability, we think of whole numbers, but temperature can go into decimals, and then that gets a little messy. The distance, a 2015 Honda Civic, can travel in city driving conditions with a full tank of gas. Does anyone have an idea about that one? This one's going to be continuous as well. Distance is a continuous variable. You can go a bunch of feet, but then feet can also be broken up into fractions as well. You can have decimal feet or even inches, miles, kilometers, meters, yards, so on and so forth. But the number of trees in a randomly selected acre of a Yosemite National Park, you can count the trees. One's going to be discrete. So that one's discrete. So pretty much if something can be expressed using a decimal, chances are it's probably a continuous. It's a continuous variable. Like temperature can be, distance can be, but the number of people in a room, trying to figure out a fraction with that doesn't make any sense. Same with a number of trees. So let's move on to the next section on sampling methods. So as I mentioned in the previous section, you want to pick a good sample in order for that to be a fair representation of your population. So you can make some meaningful inferences or generalizations about your population. So we're going to talk about, so there is a process for there's a process for how do I determine my sample. And there's actually methods for doing so. There's sampling methods. And probably the most common one So this is going to be random sampling. And as you would imagine, random sampling, this is using chance to select individuals instead of any sort of biased form of selecting individuals. So as it says below, the key to obtaining a sample representative of the population is to let randomness play a role in determining the individuals. And what that leads into, so more so I want to focus on simple random sampling. A sample of size little n from a population of size big N, so little n would be the number of people in the sample, and big N would be the number of people in the population. This is obtained, the sample is obtained through simple random sampling if there's an equal likely chance of any person in the population being chosen. You might think, would it be random if I went up to random people on the street and started interviewing them about how many hours they spend outside a day? This would not be a simple random sample. The reason why is because there may be some bias when you talk to people that are outside and not the people that are, well, very much frankly sedentary in their lifestyles and are not likely to go outside in order to be interviewed in the first place. So instead, generally how simple random sampling works and in practice is every person in the population is assigned a number, and a seed using some technology is chosen to randomly select these random people in the population. So you make a list of everybody in the population, and then I'm going to simplify the terminology. It's there in the paragraph if you want to read about it, but every person's assigned a number, and then you use technology to basically randomly choose however many people you want in your sample. So if there were 30 people, you would use technology to say, generate 5 random numbers. And those numbers would correspond to the people or the objects in your population. So that's how simple random sampling is done in practice. There's also, and I have a few more. So let me try to roll through these in 2 minutes. This should be fun. There's stratified samples. This is when you have a population that may consist of a few larger subsets. So one example I include, if you interview people in the state of Texas on a political, or what they think of a certain political policy, it may be better to split them up first into Republicans, Democrats, and independents, people who will that will probably have very different views on something regarding politics, and then you perform the statistical study on the subgroups that you just created. So that's stratified. And then you obtain simple random samples from each one of those groups. So that's stratified. A systematic sample is you select every third person, every fifth person from a group of people. So systematic samples are used when your population may not be known. So the example I use here, the number of customers that may attend a store on a particular day. Yeah, there's no way I'm going to finish this in -1 minute. So I'm just gonna finish this up on Monday. So I'll leave it there. Get started on the homework. I'm probably gonna make since I'm gonna finish this section on Monday, I'll probably make the homework due probably Monday night or Tuesday. I'll think about it. Other than that, have a good day.